Hello everyone, and welcome back to another episode of Gabe's World. We had some breaking news earlier this morning when NASA announced that a 2-kilometer wide asteroid known as 1997 XF11 will pass between 50,000 and 80,000 kilometers of Earth. Now, we all remember what happened the last time a meteorite struck the Earth, resulting in an impact 1 kilometer wide and 200 meters deep, killing everything within 50 kilometers. A lot of people, including myself, are scared about the potential impact of this asteroid, so I decided to bring in Professor Philmon DeWitt, who teaches astronomy at Harvard University, to answer some of the questions we all have. Thanks for coming on the show, Professor.
Thanks for having me, Mr. Camus.
Now, when most of the public heard the news this morning, they panicked. However, many people don't truly understand what an asteroid is. Could you explain and also let us know the difference between an asteroid and a meteorite?
An asteroid is a small rocky planetary body in orbit around the Sun. They usually don't reach over 1 kilometer in size, so it's quite alarming that 1997 XF11 is double that. Most asteroids in our solar system are found in the main asteroid belt, a region between Mars and Jupiter, but can occasionally come close to the Earth. Meteorites are simply meteoroid rocks that don't vaporize completely. Asteroids are typically much larger than meteorites.
Interesting. I think that in order to really know the impact that this asteroid could have, we must look at how Earth formed to get a better understanding of interactions between objects in space.
You're right, but before we can talk about how Earth formed, we must talk about how the universe formed. Most astronomers believe that the universe formed between 13 and 14 billion years ago in an event called the Big Bang. The Big Bang theory proposes the idea that the universe has expanded from a condition that existed at time zero. At time zero, temperatures were extremely high. Once the universe began expanding, these temperatures began to drop. As the temperatures began to drop, matter began to form from the original energy.
Alright, now, what is the evidence of the Big Bang Theory, and why do most astronomers believe it's the explanation for how our universe formed?
There are multiple pieces of evidence that support the theory. For example, there is an abundance of elements in the universe that are believed to have came from the Big Bang. Also, the universe is accelerating and expanding, which proves that it has a starting point and evolved from that. Most astronomers accept the theory as the formation of the universe simply because the evidence stacks up in its favor.
Even though most astronomers accept the theory, are there any other theories? How do they differ from the Big Bang Theory?
Another popular theory is the steady-state theory. This theory states that matter in the universe is continuously being created at a rate that allows the density of the universe to remain constant as it expands. It suggests that the universe always existed, and unlike the Big Bang Theory, there was no moment of creation or time zero.
Why do people generally tend to believe that the Big Bang Theory is the explanation for the universe's formation when there's other theories out there, such as the steady-state theory?
Well, there are strong arguments against the steady-state theory. They include the discovery of the cosmic background radiation and the discovery that galaxies were more crowded together in the past. So while nobody knows for sure how the universe began, scientists tend to lean toward the Big Bang Theory as the explanation.
So, once our universe formed, it was separated into galaxies, right? And our galaxy is the Milky Way. What can you tell our listeners about the Milky Way?
The Milky Way is a spiral-shaped galaxy containing hundreds of billions of stars. It is best described as a band of light that stretches across the dark night sky, which is formed by the glow of the billions of stars it contains. It would take around 25,000 years to travel from Earth to the center of the Milky Way.
Wow, that really shows how large space is.
Indeed, and the Milky Way is just one of the galaxies. Other galaxies include the M81 spiral galaxy, which is 11.6 million light-years away, the Centaurus, which is 11 million light-years away, the Izwiki 18 irregular galaxy, which is 45 million light-years away, and billions of other galaxies.
Which galaxy is the closest to the Milky Way?
That would be the Andromeda galaxy, which at the speed of light is only 2.9 million light-years away.
We talked about the origin of the universe, but how about the solar system? Is there a theory that explains how our solar system formed?
Indeed, there is. The nebula theory is a scientific idea that our solar system formed from a giant rotating cloud of gas and dust. The nebula theory is widely accepted by the scientific community because it explains the properties of the universe very well. The creation of a solar system detailed by the theory is a 100 million year process, starting with a cloud of interstellar gas and dust. The cloud then forms high areas of concentration. As the concentration increases, gravity increases and converts to the kinetic energy of fast-moving particles. The particles then collide with one another and generate heat. This cluster of particles grow in size and reach temperatures of 10 million degrees Kelvin. After a period of stabilization, this cluster becomes a star.
I assume that this is what leads up to the formation of planets and other small bodies within the solar system.
Yup, as the star continues to grow, the particles and elements surrounding it form into globules with composition depending on the distance from the star. These globules collide with each other and stick together to form larger spherical bodies in a process called accretion. The larger bodies with diameters of a few kilometers are called planetesimals. Planetesimals slowly become planets by colliding with each other and attracting materials. The planetesimals become comets when they're too far away from the star for gravity to force collision, and other bodies, such as asteroids, form due to pieces of planetesimals breaking off.
Wow, so all of space formed from a cloud. You know, information like this really makes you realize how big our universe is. But if these galaxies are so far away, as are most things in space, how do astronomers learn about them?
Great question. Members of the astronomical community learn about deep space through innovative technologies and methods that unlock many mysteries. Humans have been creating technologies that allow us to understand space for centuries. For example, telescopes have allowed us to see space in a way we would never thought possible. Also, robotic probes have allowed humans to learn about planetary systems and gain a greater understanding of the universe.
Interesting. So it appears technology has truly allowed us to understand space.
Yes, it has, but it doesn't stop there. We have developed methods that help us measure the distance between large bodies. We use a parallax to measure a star's apparent movement against the background of more distant stars as Earth rotate around the sun. Parallaxes give us astronomers angle measures of a star's apparent movement. We use them to understand Earth's position in space during a particular season in relation to faraway objects. Astronomers also use the Doppler effect, which is used to determine the velocity of an object as it passes by Earth in terms of wavelength. The Doppler effect comes with two shifts, a redshift and a blueshift. An object passing by Earth is redshifted when its wavelength increases and the frequency decreases. The object is blue shifted if the wavelength decreases and the frequency increases.
Alright, quick question here. What will ultimately happen to the universe? I mean, couldn't it just end one day?
It may be a quick question, but it's not a quick answer. There are three potential endings to the universe. First, the universe may never end. Some scientists think that the universe will continue to expand forever because it is filled with dark energy, which causes the expansion of the universe to speed up. And other scientists think that if matter in the universe reaches a point where it starts to decrease over time, it could cause gravity to become the dominant force. This will ultimately cause the universe to shrink and cause objects in space to collide into each other, and the universe would eventually collapse. The third outcome states that the universe will eventually become so vast that supplies of gas would spread very thin, resulting in no more stars being able to form. This would mean that the universe would be left with little to no energy.
This is some very helpful information, and it definitely helps our viewers and me gain more insight on this asteroid. With an understanding of our universe's history, we can gain a better knowledge for how objects in our universe, such as asteroids, work. To recap, we learned a lot about our universe's history. For example, you discussed the nebular theory, which explains how our solar system formed, and eventually led to the formation of asteroids.